Hey guys, in this video I'm going to show you how to derive the quadratic formula. At this point you've probably learned how to solve an equation using the quadratic formula, and your teacher may or may not have shown you where that formula came from. It's a really cool derivation, and sometimes it's important to know where a formula comes from. We start with a generic quadratic equation, ax squared plus bx plus c equals 0. And you'll notice that I set this derivation up like a two-column proof from geometry, where all the steps are going to be on the left side and all the justifications for those steps are going to be on the right side. So in step 1 we have ax squared plus bx plus c equals 0. Just a garden variety quadratic equation. The next thing that I'm going to do is I'm going to complete the square. But I can't complete the square unless the leading coefficient is 1. And to guarantee that that a out in front is actually a 1, I'm going to go ahead and divide everything through by a. When I do this, I'm left with x squared plus b over a x plus c over a equals 0. Now the next thing that I want to do in order to complete this square is isolate the constant and leave some space so that I can actually complete the square. What I've just written down in blue is essentially the same thing that I had in the step before, except I've moved the c over a over to the other side, making it negative, and I've also spaced the things out a little bit differently so that I can leave room for completing the square. And the next step in that process is to take half of the linear coefficient. What that means is I'm going to focus my attention right here at the linear coefficient, and I'm going to take half of that. Well, 1/2 of b over a is b over 2a. And when I complete the square in my class, I always have the students put that value in a little circle. And that's going to become important in the next step. Now what I'm going to do is take that value that's in the circle, I'm going to square it, and I'm going to add it to both sides of this equation. And if I square b over 2a, in other words, I multiply that fraction by itself, I end up getting b squared over 4a squared. So I'm going to go ahead and add that to both sides. Okay, the next step, now that I've completed the square, I'm going to factor the left-hand side using the perfect square trinomial method. And if you're not sure what that is, you can look at another video just on that topic if you need some refreshing on the perfect square trinomial method. And then on the right-hand side, I'm just going to simplify those two fractions by writing them as a single fraction and getting a common denominator. So I'm going to go ahead now to step 4, and I'm going to factor the left side as a perfect square trinomial. Okay, now the right side is a little tricky because to add or subtract fractions, I need to have a common denominator. So I want to ask myself, what is going to be the common denominator between a 4a squared and just an a? Well, as you may have guessed, the answer is 4a squared. Now, to get the old denominator on the left to look like this new denominator, you don't have to do anything. So I'm just going to leave the top b squared. Then I've got a minus sign. Now here there's going to be a little bit of a problem. In order to get an old a to look like a 4a squared, I have to introduce a couple things. I need to introduce a 4, and I have to introduce an additional a. So if I do that to the top and the bottom, the new numerator is going to become 4ac. Okay, in step 5, it's suggested that we use the square root property. And what this means is to take the square root of each side. Now when you take the square root of a chunk that's already being squared, all you're left with is the chunk itself, x plus b over 2a. Now, when you use the square root property, you need to interject a plus or minus, so I'm going to go ahead and write that. And now I'm going to use the square root property on the right-hand side, which is a fraction. And one of our rules of square roots is that when you take the square root of a fraction, that root is applied to both the numerator and the denominator. I'm going to focus my attention on the denominator first, which is 4a squared, and the square root of 4a squared is just 2a. And the numerator, I really can't do too much with that, so I'm just going to write it under the radical. Okay, moving to step 6, they tell us to isolate x. which means I need to get this plus b over 2a to the other side. Now you might be noticing that this step 6 is looking really similar to the quadratic formula. That means we're almost done. And the last thing that they suggest doing is writing as a single fraction. Now we've seen this step before, writing as a single fraction, and in order to do that, we have to have a common denominator, which luckily we have. So the denominators of both the left and right fractions are 2a, so that's going to be my common denominator for this new single fraction. So in the end, we end up getting x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is precisely the quadratic formula. So this was the derivation, and we essentially did it by completing the square. Now for those students who are actually still watching this video and you haven't turned it off yet, I did make an allusion to putting this value in a circle. Factoring this as a perfect square trinomial can be challenging for a lot of students, and my little trick when I have my students complete the square to write this in the circle is that you're going to use the variable that was used in the actual problem above, which is x, and that just comes down to here, and then the value in the circle just gets repeated down here. So while you're actually factoring, if that confuses you, you could just rewrite the variable, which in this case is x, and rewrite the quantity in the circle, which is plus b over 2a, and then square the whole thing. So that's just a little teaching tip that might be of help to some people when completing the square. So overall, here's your derivation of the quadratic formula. I hope you enjoyed it.